So hello, ladies and gentlemen, and welcome back on the industry stage here at the Formnext 2023. We hope you had a wonderful lunch break, are now able to join our program again and enjoy the very interesting afternoon and all the exciting topics to come. If you want to have an insight in our industry, and that's probably why you are participating here, you can't miss our next speaker. He has made it his mission not only to have an overview of our industry, but also to share it with us. For years, he has been providing market participants with insights, the current status, and valuable tips on new application. Welcome to the stage with me, Mr. Terry Wohlers, Head of Advisory Services and Market Intelligence at Wohlers Associates, powered by AST International. Terry, it's a pleasure to have you. Thank you.
Great, very nice. Well, thank you everyone for being here. It's really a privilege to be a part of this very important event. In fact, this is the most important week in additive manufacturing, in my view, worldwide. So you came to the right place. I just have so much fun, and I wish it would go for 2 weeks, although my wife would not know who I am after 2 weeks. But it's really a privilege to be here. Thank you for attending. I want to share just a few minutes of comments on my view of where things are at, maybe a bit about the future. The industry is growing. It grew by more than 18% last year to more than $18 billion worldwide. Still a very, very small part of overall manufacturing worldwide. Just a little bit more than, not 1%, but 0.1%. It's about 0.12% of the entire manufacturing economy. So there's big potential for growth ahead. A little bit about our team. Wohlers Associates 2 years ago was acquired, and it was announced here at Formnext. And it was acquired by ASTM International, a group that is now 125 years of age. So now we're 37. We have a much bigger team, more resources, and it's going extremely well. So this is the team. You see the Center of Excellence and Additive Manufacturing team at the top, and then the Wohlers Associates team, but really just one big team. We work together on projects depending upon what it is. We have people in healthcare, heavy industry, aerospace, a lot of deep technical knowledge and business development knowledge as well. So it's great to be a part of this organization. So this is some recent work from one of our associate consultants, and he also leads the instruction. We do design for additive manufacturing training, 2- and 3-day courses, and it's really very hands-on with the software, best-in-class software tools, and learning how to do these kinds of designs with, in this case, a gyroid. And what this is a custom footwear where the size and wall thickness is controlled by the a pressure map of the foot. And you can get from this to a printable design in a matter of just a short time, very, very quick. Here's an industrial example of using a gyroid, gyro design for a radiator on the left and a heat exchanger on the right. And Olaf said that he imported the CAD, and literally 1 minute later, it generated this gyroid design. So it's very fast. I had the privilege to speak at an event on Monday here in Germany. It's the Additive Manufacturing Green Trade Association, and the founder of that is a person from Centavia, the founder and CEO. He explained that he's doing a heat exchanger, and it'll be on the F-35 fighter jet soon. And that's no small task to get something like that certified for flight. So these aren't just examples of what's possible. They're actually being done in real serious types of programs. Moving from that to automotive, for years, people in automotive have talked about how big it will become. Now, they've been the early adopters even the late 80s, early 90s for prototyping applications and some tooling, but most automotive companies will admit they're not using it much yet for series production. A few exceptions, but now we're starting to see some traction, particularly still with the car companies that do the high-end specialty luxury type vehicles, sports cars, that sort of thing. One example is this, it's not, I don't have a picture with me of the aluminum chassis for Aston Martin. This is another chassis that was done, optimized for additive manufacturing. This is the Zinger C21 sports car. It's very expensive, high-end, but using the same concepts to produce a chassis and suspension integrated with braking systems, with hydraulic fluid running through them inside, and really wild stuff. But in any case, this company called Divergent, it's based in California, is pushing the limits. It's one of the most advanced companies, in my view, in terms of pushing the limits with design tools and additive manufacturing, building these big structures like this using powder bed fusion, metal powder bed fusion in aluminum alloys. And so, and this is one reason why companies are attracted. Many OEMs, automotive OEMs here in Germany are quite interested in what this company is doing, because they can do in 3 months what before has taken 2.5 to 3 years to do. And so now they're working with, but just last week, a person from Mercedes-AMG spoke at the ICAM conference. The ICAM stands for International Conference on Advanced Manufacturing. It was in Washington, D.C. Keynote speaker was a gentleman from AMG, as well as Kevin Zinger from Divergent. So just amazing work, and they're not only doing work in automotive, they're doing some aerospace and defense work as well. This is a drone body, a big industrial drone for through a government contract, consolidating 140 parts into 4, reduced manufacturing time by 10 times. And of course, other benefits come along with part reduction, of course, part count, but then also you're reducing all of these manufacturing processes that would be tied to these 140 parts, which means a reduction in inventory, labor, maintenance, certification paperwork. All of that declines dramatically when you can do these kinds of designs. So it's fun to watch that kind of work underway. This is some work at GE, world-class designers at the company. As far as part consolidation, you can see the numbers there, 850 parts down to 12, and a reduction in weight, which is very important. And then also some other benefits in terms of fuel burn and power improvements as well. This is a helicopter engine, and you can see here that they reduced 300 parts down to 1. I mean, amazing work. The big benefit, not only the reduction in manufacturing processes and inventory, but also supply chain. They reduced the suppliers from 50 to 1 to just 1. And so supply chain simplification is really something that we haven't seen until additive manufacturing began to gain traction in this area. Additive construction is an interesting one. I have opinions, and if we had time, I would spend 20 minutes just talking about this. My father was a building contractor. I grew up with construction, so I have an appreciation for what it takes to produce a building, both residential and small commercial. And in the early days of additive construction, we saw a lot of examples of homes with just square, straight walls, and it's like, well, why would you do that? The same benefits to the complexity and odd shapes and all of that we see here at Formnext also apply at the large scale. And if you're not taking advantage of additive for, not using these benefits, then, can you really gain a lot of value? Can you build a business case? Has anyone seen real hard independent justification numbers, from, an independent source on additive construction? I have not. It's always people who are, tied to, have a vested interest in this. Now, we are starting to see some good designs like that, has some interesting aesthetic value. If you go through the airport in Singapore, you'll see Tiffany. And maybe it's not structural, but it has value in terms of the aesthetics. And so we're seeing now companies do some interesting work, which excites me. And I think, the carbon footprint of concrete is not good. I mean, it's really not a good thing. So I'm hopeful that companies here and elsewhere will come up with alternative materials besides concrete to as the feedstock to build these really interesting designs. On-demand manufacturing and semi-custom versus mass production. A person said to me, I don't know, maybe it was 2 or 3 years ago, he said, Terry, he said, I'm afraid with all of these machines that we're seeing, these 3D printers, that we'll be building all these parts and they'll be filling up our landfills and it'd just be a waste. And I said, well, you may be right, but compare that, or not that, but maybe on demand, having digital inventories and building on demand versus molding, 1 million parts and throwing half of those into a landfill. So there's an opportunity to really have, to move inventories into a digital format and manufacture on design. Also, people will pay more for custom designs, like these guitars. There's some out on the show floor. There's some at our exhibit here on 11.0. And so Olaf Diegel, more of his work. This is his collection. The design on the right here is a new design that was shown last week in Washington, D.C. It was actually produced with the J750 from Stratasys color machine. It's photopolymer, so it's relatively fragile. Most of his designs are done in a PA12 material, so if you drop it or bump it, it won't break. And so I think we're going to see a lot more in the future of semi-custom and designs, and people will pay a premium for them, not only in this particular thin sliver of space, but automobiles and a lot of consumer products. I have the Smith ski goggles that are not custom, but they could be. And so, no, I take that back. They are. I used an app to scan my face. I did send it to Smith, and they made these custom that fit my face perfectly. And so they used HP Multi-Jet Fusion for the structural, the plastic parts. So with that, my time has almost expired. If you have questions, be more than happy to answer them. But I'd like to close by saying this, that we're seeing some really interesting advanced tools and methods around design for additive manufacturing. It's really driving this industry. If you're not designing for it, for production volumes, it really doesn't make sense in most cases. And we have to really think differently about how we go, as far as business, the new types of business streams and business models. And so I'm excited about that. And then, I think what we know is exciting, but what we don't know about this industry and the technology is even more exciting. Some of the young faces in the crowd, I'm hopeful that you will help advance this industry. Some of us guys at my age, we won't be around forever. So you really would need to help move this industry forward. And so I look forward to watching your work in the years ahead. So thank you very much.
Big applause for Terry Wohlers. Terry, you know what? I like your last sentences the most. Because we are talking so much about future innovators in our industry and how we gonna push them and encourage them.
Right.
And in fact, this is always happening to me when I follow your presentation. You bring these inspiring examples. I mean, and we can think about construction whatever we want, but if you see it and you see the Tiffany example, for example, you feel directly the reason why you are in this industry, because it's so amazing. It gives you all this new innovation and opportunities. Great speech. Great,
thank you.
inspiring speech.
It's fun.
I have some questions for you,
Yeah?
if you don't mind.
Sure, yeah, of course.
So if you meet Terry Wohlers, you have to ask, what was the most amazing innovation you have seen so far at Formnext?
This year?
This year, yeah.
Oh, wow.
That was a heavy one for the start, sorry.
Well, I've seen many, honestly.
Yeah.
Sometimes the simple examples, it's it's like, well, why didn't I think of that? Or why hasn't this been done yet?
Yeah.
I was over at the Materialize stand. I forget where the 12-1, I think they are. But in any case, they showed these examples of big, heavy metal parts that now they're printing in like a PA12 with the same strength. Now, how do you do that? Well, they're building channels inside the parts, and then they're pumping, well, they feed a continuous carbon fiber filaments through it along with this resin. And that is very lightweight, and it provides the strength that the metal does. And so they're a fraction of the weight at, and the design is, much nicer looking as well. And so that's an interesting one. It's like, that's so simple. And so.
And only possible with additive manufacturing.
Because of the channels. That's right.
So true. You tackle one topic that I like really much because I'm from economics. You mentioned the less suppliers, less components, and we had the example of Danfoss, who they reduced a part from 36 components to one in one single printing process. So is that considered by the end customer and already perceived as an additional advantage in the overall cost perspective? Let's put it that way.
Well, it's an evolution for most companies. Most are still learning about the possible benefits, and then they say, oh, we got to look at this. They start to look at it. We got to invest in this somehow. So they begin to do that, and then they say, well, but to really take advantage of it, we have to design to consolidate these parts. They say, well, how do we do that? Well, we need these tools, software tools. We need people that know how to do that.
Yeah.
Now, they may do some first parts, outsource, have somebody else do that for them, but ultimately they want to keep the designs close to them. And so that's a challenge, because especially if you have really complex designs. And so then they have to put the brakes on and say, okay, this is... To come up with a cost justification, it's hard to do that in advance of actually doing all of this design work and building the parts. And so I think that's one of the biggest obstacles to the adoption of the technology is that.
Yeah.
And it's not only part consolidation, it's, optimization, using topology optimization and lattice structures and these gyroid designs and increasing the performance. How much will it improve? And how do we measure that? Well, you have to go through that whole exercise. And so that's now companies are doing that, but far more, thousands of companies are not, because they don't know how to go about it. They don't want to take the risk. It's easy to just go back to do it the way they've always done it.
Absolutely. But this might be a key for the future.
Yeah, maybe so, yeah.
Ladies and gentlemen, unfortunately, we're running out of time, and I can imagine you have 10,000 questions to Terry Wohlers. I can't, unfortunately, ask them all. Terry, tell us where we find you in order to get more question answered.
Oh, yeah, we're just here on Hall 11, and it's in the near the USA Pavilion.
Okay.
The American Pavilion. It's just right over here. It's a 30-second walk. So we're right over there, and in the row A. So Wohlers Associates. You can't miss it. Good German name, right?
I know he's very occupied, but if you have any more questions, please visit Terry. Terry, was a pleasure to see you again. Good luck for the rest of the fair.
Yeah,
thank you. Bye-bye. Thank you for your presentation. Thank you. Bye-bye.
Thank you.
Yeah, ladies and gentlemen, after Terry's amazing insights, we will provide you now with some additional highlights of Formnext, and please stay tuned, because after that we have another exciting expert insight for you. So stay tuned. See you in 3 minutes.